Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will study about conjugate subgroup. Let's start. What is a conjugate subgroup? Let G be a group and H be a subgroup of G. Then for each G belongs to G, the set K is the conjugate of H is equal to G inverse such that H belongs to H. First we need to know what is conjugate. A conjugate is, let me say that this is a group G and A comma B belongs to G. These two elements belongs to G and A comma B belongs to G. Then B is the conjugate of A if an element G and G inverse also belongs to G, we put G here and G inverse here. Then this combination G inverse give us B conjugate. Here A is the conjugate of B and B is the conjugate of A. Similarly, A is equal to AG B G inverse, where G and small g also belong to G and A. Here A is the conjugate of B. These are the elements of G. But here we are talking about these subgroups. Let G be the group and H be the subgroup of G. Then for each small g belongs to capital G, or G is the element of G, the set this K is the subgroup of G and H is also subgroup of G, then these subgroups are conjugate of each other. K is the conjugate of H and H is the conjugate of G, and conjugates elements or groups are looks like this. So where small g H G inverse, where H belongs to H and this G and G inverse belongs to G, is the subgroup of G. This K will be the subgroup of G and it is called the conjugate subgroup because we have taken the conjugate of its elements. So the conjugacy class of subgroup H is the collection of all subgroups of G which are conjugate to H. What it mean? Which are conjugate to H? Here he is saying that, for example, K1 is a subgroup, K2 is a subgroup, K3 is a subgroup, up to so on, and we take K1 by this G H1 G inverse. Similarly, we get K2 by G H2 G inverse, and similarly we take K3 by G H3 G inverse. K3 is the conjugate of H3, K1 was the conjugate of H1 and K2 was the conjugate of H2. Then this combination, this class is called conjugacy class. A conjugacy class of subgroup H is the collection of all subgroup of G which are conjugate to H, and K1, K2, 3 are all conjugate to H. Let's discuss a theorem. Any two conjugate subgroup of G are isomorphic For isomorphic mapping, we have to prove that these, we are talking about these K and this H. We are going to talk about these two subgroups. These are conjugate of each other, and these are conjugate of G, conjugate subgroups of G. So we are going to prove that these are isomorphic to each other. For isomorphic, we need to prove that K has mapping 1 to 1 with H and has onto. Obviously, it is onto because all the image of K, elements of K are from H. We are taking from H. So first we prove that it is 1 to 1, then onto, then it's bijective, and on the third part will be homomorphic. These should be homomorphic also. Homomorphic means they preserve their operation as well. So here the mapping is defined. Mapping is defined like this. Let H and K are two conjugate subgroups of G. Then for some G, K is the conjugate of H. Mapping phi from H to K is given by phi of H is equal to GH G inverse, and GH G inverse are the elements of K. H, small h are the elements of H, and this belongs to this. This is domain and this is our range. So obviously phi is well defined. Now we are going to prove 1 to 1. So phi of H1 is equal to phi of H2, and when we apply phi, it gives us the conjugate image which is GH1 G inverse, and here GH2 G inverse. By cancellation law, or by multiplying here with G inverse and here with G, and this side G inverse and this side G, we get H1 is equal to H2, which proves that it is 1 to 1. So also phi is onto because the GH G inverse are conjugate of H is the image of H because these number of elements are same. So phi is also onto, and when it is 1 to 1 and onto, it means that it is bijective. Now we are going to prove that phi is homomorphism. For homomorphism, we take two elements from H, H1 and H2, and apply phi on them. When we apply phi on them, this gives us the elements of conjugates. Let G, H1, H2, G inverse, and this G into G inverse we put in between H1 and H2 because these are inverses of each other, can be put anywhere. Their answer is identity element. So by this GH G inverse will be phi of H1, and GH2 G inverse is phi of H2, hence proved that it is a homomorphism. Phi of H1 H2 is equal to phi of H1 and phi of H2. This is the condition for homomorphism. Hence H and K are isomorphic. Note, what is the note? Note is two conjugate subgroups of group have the same order. Obviously these are image of each other, so and bijective mapping has been done between them. So these have same order, these have same number of elements. I hope you understood. Thank you so much.